Hey everyone, Neural here. Recently I did a review on a ProTemp Sunstream kerosene heater. It is down here. I'm in my garage right now, and this is just a quick video to answer a viewer question. And I thought it was a good question, and the question was, how does one of these units run on a modified sine wave inverter? So I covered in the previous videos that this thing really does run pretty cleanly. I've even put this inside my house and ran it for like an hour straight. Pretty much no smell at all. It's even cleaner than my wick type kerosene heater, which I'm really quite impressed with. Works very, very well. There is quite a bit of radiant heat from this, so you have to keep it away from walls and stuff by a few feet, otherwise your walls get burning hot, and so does your floor. I did end up putting this piece on the bottom. That allows me to put it on surfaces without burning the floor up, so yeah, a lot of heat comes out of this thing, and sometimes it might be nice to use this to heat an area off of an inverter. Let's take a look at the label on the back to see how much power this thing requires. This is the operating label on the heater, as I had shown in the previous videos, but what's important here is that it takes 120 volts, 60 hertz, and 1.7 amps. Now 1.7 amps isn't very much, that's about 200 watts. And all it has to power is a couple of fans, a fuel pump, and an igniter. There shouldn't be anything in there that's all that high a surge, so I should be able to power this thing on a pretty small inverter. And that's what I'm going to try. I'll show you the inverter here in a little bit. But I want to mention that if you're using something for emergency heat, I like wick type kerosene heaters because they require no electricity at all. And they're always going to work. It's just a damn wick, so you don't really have to worry about it too much. But in this case, this can be powered off of a really small inverter, I think. We'll try that out here. Just a really cheap $20 modified sine wave inverter. And I do like using kerosene for heat, or diesel fuel as I used in my previous video, but that's because if you use a gasoline generator, you're lucky to get 10% of that energy out of the gasoline in terms of heat. So it'll take you 20 gallons of gasoline or 2 gallons of kerosene. Now, how much fuel do you want to store on site? I can easily store 10 gallons of kerosene on site, and I do at my house for whatever purposes. In fact, the tank on this thing here holds 4 gallons all by itself. But for 10 gallons of kerosene, I'd have to store 100 gallons of gasoline to get the same benefit out of a generator. So yeah, impractical. Just use kerosene and direct burn it, either in a wick type heater or this type. So to power my Sunstream ProTemp 70,000 BTU heater, I'm going to try to use this guy. It is just a really cheap 400 watt inverter. I got this broken and fixed it. Just some flimsy little leads here. I'm going to clip those up to a vehicle battery and see how it runs. Also, we're going to take a look at the power consumption. Here I have my P3 kilowatt hour meter. We're going to hook this up to the inverter somehow, plug it in, and see how much electricity this thing draws. Now, what do I expect before I do this? Well, because it's modified sine wave, I expect the fans in this thing to run slower than they should, and perhaps the fuel pump will run a little bit slower. Now, it burns extremely cleanly, which, again, I'm pretty impressed with, but with a slower fan speed and a slower fuel pump speed, I'm kind of wondering if it's going to atomize the fuel adequately to still burn cleanly on modified sine wave. I think it'll work fine, but that's why we're going to test it out here. I do want to mention that this fuel tank is full of K1 kerosene. Oil prices dropped recently, and things are getting a lot cheaper, so I'm just going to buy the good stuff at this point. I plan to run this thing on diesel fuel, and I demonstrated in the previous video that it does run pretty well on diesel. For the first 30 seconds or so, it does emit a fair amount of soot and whatnot on diesel fuel, but after that it settles down, burns extremely cleanly. I have K1 in there right now, and I've tested that out, and K1 burns cleanly from the get-go. On the previous video, you saw that there were flames shooting out of here about this far on startup. After it fully warmed up, the flames are all inside. When I run it on kerosene, the flames are all inside all the time. So it does burn a little bit cleaner, but once it's warmed up, you can burn either one. So if you're heating the shop with this, I just fill it with diesel, but I don't go through a lot of fuel, so I'm just going to buy K1 at this point. Alright, let's hook our inverter up. This is the vehicle that I drive to work every day, so I'm just going to hook it up to this one. It'll recharge the battery when I drive it tomorrow. And you may notice some rather unorthodox cabling here that goes directly to my alternator. That is from a previous project. I have a video on that, on how to connect a electric heater to any vehicle. You can watch that one if you want, but you can connect a 400 to 600 watt electric heater to your vehicle, any vehicle at all, and it only takes a few minutes to do, which is pretty handy during the winter. That way you don't have to wait for heat. Anyway, I'll just clamp this directly up to the battery and plug in my heater, see how it works. We're also going to use my kilowatt P3 meter here, just for interest's sake, to see what this thing actually draws. So let's turn the inverter on. And obviously I don't have a good connection. So let me see if I can reconnect these things. This car is like 23 years old and everything is rusted on it, including the battery terminals. So I'll see if I can get a good connection and then I'll turn the camera back on. Alright, let's see if that did it. Looks like it works. This cheapo modified sine wave inverter is outputting about 118 volts. So let's go over to the heater, turn it on, and see how well it performs on this tiny little $20 400 watt modified sine wave inverter. Connected up to my old ancient car here. Alright, let's see how this works. The fans sound like they're exactly as loud, running exactly as fast as they would normally. And we'll see how it starts up here in a couple of seconds. There's the igniter. And there's the flame. It is running, as far as I can tell, exactly the same as it does off of wall power on this modified sine wave inverter. It's throwing out good heat. I can stick my face directly in the airstream. There's really no smell already. And yeah, this thing works great. Let's go over to the meter over here and see how it's doing. Looks like the voltage went up to 125 volts under load. It is taking 1.6 amps. It's rated for 1.7, I believe. And it's only drawing 110 watts. So this little 400 watt inverter does just fine. You can even use a smaller inverter. In fact, this is below what a cigarette lighter adapter could use. You could actually plug this thing in your cigarette lighter adapter. You don't even have to hook it directly up to the battery, which is kind of surprising. But there we go. There is this heater running off of an inverter. Now the torpedo style heaters, I'm going to stand in front of it because it's cold in my garage. Hopefully that's not too loud. But the torpedo style heaters, they do take more power than this larger diameter radiant heater does. But you could probably still power it off of a 400 watt inverter without an issue. And as far as I can tell, it burns exactly as clean as it did before. Works it really well. And I got no complaints at all. So there you go. Running off of this 400 watt modified sine wave inverter. Not a problem at all. And no, I wouldn't worry about longevity and whatnot on something like this running on modified sine wave. It's going to work just fine on it. Pure sine, modified sine. I expected the fans to run a little bit slower, and it's possible that they are running slower, but I can't really tell too much. After all, the voltage is 125 volts, so that probably makes up for some of it, but there you go. My heater seems to work just fine on modified sine wave, so thanks for watching. And in case anyone's wondering, it's currently on its cool down cycle, so the fuel pump shut off and the igniter shut off, and on the cool down cycle it takes about 70 watts of power to run and 1.25 amps. This here is my battery bank. This is what I would use to power that particular heater in most applications when the power's out. This is about 1400, I believe, amp hours at this point with a 3000 watt pure sine wave inverter. And I'd probably just use this to heat my house if the power goes out at this point. But for most people, I'd recommend something like this. This is just a standard old wick type kerosene heater. It works really well. You can store this in your basement for 20 straight years. Pull it out one day and you know that it's going to work with no maintenance or any sort of preparation. As long as you have kerosene, you can fill it up and light it and it'll work just fine. But I really do like that heater, the ProTemp Sunstream that I have. Works really well, and it actually smells less than this guy does. Now, this isn't all that bad. I've used this for heat experimentally for a day or two straight, and it works just fine, but the other heater works pretty well also, so I'm probably just going to use that one as long as it's working. Now, it does have a lot of moving parts. It could fail at any time. This isn't going to fail, so this is a lot more reliable, but I kind of like the other one. And I just want to note, for safety reasons, always have a carbon monoxide meter. This is a battery-powered carbon monoxide meter. That way I know that I am safe. I also have a carbon dioxide meter. Most people don't have that, but basically make sure you have a carbon monoxide meter. That's the most critical thing possible. This one always read 0 on the kerosene heater or on the ProTemp Sunstream. I won't go into details on carbon monoxide levels, but neither one of them emits any significant amount of carbon monoxide.